In August 1977, we took a huge step in mapping outer space when NASA launched two space probes, the Voyager 1 and 2. The mission was to give us a glimpse of our neighboring planets and go out into deep space so we could figure out what's out there. What's up guys? Hello and welcome back to the channel. We are back with a new video, and this time we have brought Voyager spacecraft's shocking new discovery in space for you. So the Voyagers are still on course, their mission is still ongoing, and at the mature age of 44, they have given us more than we had hands to hold. Both spacecraft had identical systems with different trajectories. Voyager 1 gave us the close-up of Saturn's rings and its largest moon, Titan. Voyager 2 was sent to do a grand tour of our sister planets. The project was initially built to last for a total of 5 years. You heard it right. Going from a 5-year mission to a 44-year mission that's still ongoing. The Voyagers have been remarkable in many ways. This is the first in the long list of accomplishments. The Voyager's journey may have started from humble origins, but it has gone galaxy-wide ever since that. It still continues to cruise effortlessly through the darkness, and the vacuum is a testament to NASA and the engineers that worked on the Voyager projects. The team is undoubtedly infinitely proud of what Voyagers have allowed them to learn. Before we begin to understand what kind of discoveries the Voyagers have made, we need to understand just what kind of readings they were designed to pick. But housing electronics is the part of the craft that supports the various scientific and engineering systems. Each side of the bus carries various electronic equipment. Bay 1 carries the radio transmitters that allow the Voyagers to send data back to Earth. It sounds like something that measures cosmic rays, but the scientific explanation is a bit more complicated and very detailed and short. This subsystem is designed to read the cosmic particles surrounding it. The Voyagers are mindful guests, and they don't disturb or slow down these supercharged particles. They merely read the area and send data back to us. High gain antenna. The Voyagers send data back to Earth onto frequencies, the first of those at 8.4 gigahertz, and deal with science and the engineering data we receive. The second frequency at 2.3 GHz sends data regarding the health and present state of the craft, imaging science subsystem, possibly the only part we are all excited to know about. So, what does Saturn actually look like? Or the rings, or the moon Titan? All that data came from the television-type cameras attached to the craft. Infrared, interferometer, spectrometer, and radiometer. Don't let the big scientific name fool you. The iris is a collection of mundane technical equipment. It is basically a thermometer used to pick out heat around it. The second function tells us whether the particles are on a surface or in the air. And lastly, it records sunlight reflected by a surface at 3 frequencies. Ultraviolet, visible, and infrared frequencies magnetometer. As the name suggests, this equipment is used to measure the magnetic fields emitted by the sun and how it changes with time and distance. Additionally, they were engineered to ascertain if the other planets have a magnetic field of their own and how the moons and other celestial bodies react to it. Photopolarimeter, subsystem. Again, scientific jargon discourages us, but essentially it's a miniature telescope fitted on the craft. The objective of this telescope is to help us figure out how the physical properties of matter are present on the 4 giant planets. Now, what did all that fancy equipment allow us to pick? Let's take that in order of equipment described above. As the Voyagers flew by Saturn, they picked up charged particles around its stratosphere. Another such reading came when the Voyager flew in the heliosphere. Perhaps the most remarkable read came from when the CRS data confirmed a space where the solar wind was blowing in no direction. That area is now identified as a space where the solar wind is actively pushed back by the cosmic rays. The universe is beautiful but brutal. The twin antennas regularly send data updating the scientists on Earth about its condition. Perhaps the most significant data it ever sent was in 1990, when scientists decided to turn off the cameras to conserve power. The reason for that is that there is simply nothing to see out there but darkness. Voyager's biggest and most visual discoveries came in the form of pictures they took from the highest quality pictures of Jupiter to date close-up of the red spot, active volcano activity on its moon Io, and its shiny ring. Voyagers had a busy time capturing Jupiter around Saturn. The Voyager took high-resolution pictures of its 3 moons, a false color view, a high-quality picture of its moon, and Enceladus, along with a montage of the system complete with the moons. Thanks to them, we can also see what Saturn's atmosphere looks like. On Uranus, we saw its outermost ring. its moon, Miranda, cloud movement in time-lapse. The most remarkable discoveries of note were the 3 new moons discovered yet to be named. They are for now called 1986 U1, 1986 U3, and 1986 U4. A 10th new ring was discovered named 1986 U1R. When the Voyager approached Neptune and started capturing shots, we found Neptune's rings, its great dark spot and patchy surface of its moon, Triton, and cloud streaks on the planet's surface. Voyager 2 discovered 2 new moons at Neptune, named Satellite 1989 N2 in Satellite 1989 N1, and ice volcanoes on Triton's south pole. As the Voyager flew past Saturn, its iris systems picked up complex organic molecules in its moon Titan's atmosphere. Voyager's magnetometer found that Uranus's magnetic field was found to significantly offset its axis of rotation. Jupiter's rings and moons exist within an intense radiation belt of electrons and ions trapped in the planet's magnetic field. These particles and fields comprise the Jovian magnetosphere. The heavy ions migrate outwards, and their pressure inflates the Jovian magnetosphere to more than twice its expected size. Some of the more energetic sulfur and oxygen ions fall along the magnetic field into the planet's atmosphere, resulting in auroras. Saturn's magnetic field is found to be weaker than Jupiter's. The existence of a magnetic field at Uranus was not known until Voyager's arrival. The intensity of the field is roughly comparable to that of the Earth. The magnetic field of Neptune, like that of Uranus, turned out to be highly tilted. Voyager studies of radio emissions caused by the magnetic field revealed the length of a Neptunian day, which is about 16.11 Earth hours. The spacecraft also detected auroras, though they are much weaker than those on Earth and other planets. Voyager's PPS systems picked up a high-resolution profile of the rings of Saturn. Uranus and Neptune Voyagers have been the most successful and productive space exploration mission ever undertaken by humankind. The amount of data is staggering, and it may as well take scientists years to decode and make sense of some of them, as they are benign facts that we are better off knowing. Others are completely life-changing, and they may shape the future of space exploration from now on. From pictures to statistical and numerical data, there is much to sift through and differ from. As of now, both spacecraft have entered the heliosphere, the region where the sun's gravitational and magnetic pull ends, and our cozy bubble of radiation and charged plasma clashes with the wild and untamed power of cosmic winds. Voyager recorded a massive temperature spike as it entered that barrier. The next milestone to look forward to is the Oort cloud, the most distant region of our solar system, said to be the home of comets. Past its boundary, our solar system truly ends, and the wild cosmos begins. If the Voyagers continue unhindered on their current trajectory, they are said to reach the Oort cloud in another few hundred years. That's it from our side. We hope you enjoyed this video, and if you did, don't forget to leave a thumbs up. Make sure you smash that subscribe button below to subscribe to the channel and click on the notification bell icon beside it to be the first one to know when we upload a brand new video. Thank you so much for watching. See you in the next video. Until then, peace.